Do you like books? I mean, really, really like books? Then you're in the right place. Each week, your host, Sam Hankin, interviews the best of today's top-selling authors and the up-and-coming superstars of modern literature. This is The Avid Reader. Here is your host, Sam Hankin.
Everyone, today we're honored to have as our guest Dr. Frank Wilczek, Nobel laureate in physics in 2004 for the discovery of asymptotic freedom in the theory of the strong interaction. His previous books include A Beautiful Question, which is a deeper order of beauty, The Lightness of Being, the idea of our own kind of weightlessness in a universe of almost pure energy, Fantastic Realities, which is 49 pieces of history, poetry, philosophy, humor, and contributions from Dr. Wilczek's wife, Betsy. And then Longing for the Harmonies, basically what's humongously big and infinitesimally small. Dr. Wilczek is a professor of physics at MIT. His latest work, Fundamentals, 10 Keys to Reality, was published in January by Penguin. And it allows us, in my mind anyway, to work kind of inductively from his four previous works. Because here we're given the big picture and then the small picture. So to summarize, we have plenty of space and time. There's not much really going on. We aren't bound to a lot of red tape. There's tons and tons of matter and energy. Our entire history as a universe is an open book available to us to study. As his hero and mine, Richard Feynman, used to allude to. You don't have to be a miracle. You just have to be curious and work really, really hard. The other one of the keys is there's lots more out there and plenty more to discover. And lastly, and more importantly, complementarity is mind expanding. Kind of the concept that two contrasted theories, such as the wave and particle theories of light, may be able to explain a set of phenomena, although each separately only accounts for some aspects, which starts to make my brain hurt. And so let's welcome Dr. Wilczek, and thanks so much for joining us today.
Thank you. Good to be here.
So since I'm a bookseller, I'm always interested in covers and epigraphs. So oh yeah, do you have a copy of the book you can hold up? I have one somewhere, but I don't know.
No, I could.
If you want to grab one, that's okay. You don't have to though.
I'll have to get up and find
No,
it.
that's all right. I think we're trying to sell your book, so it's worth it, I think.
All right, let me do that.
Okay. The interesting thing about this is that in a bookstore, everyone always tells you you can't judge a book by its cover, but everybody always does. I can't help it. And so what's cool about your cover is that at first it simply looks like a picture of perhaps a planet, our Earth, in this blue gauzy arc about it. But then when you start looking at it, it seems to contain more information. So did you think about this cover a lot? Did you actually have a chance to decide on it yourself, or how did that work?
Well, I was given a small menu of options, but I like this one very much. So it wasn't a hard decision.
Yeah, it's an excellent cover. And then again, I'm always interested in epigraphs. And your epigraph is interesting because the book is dedicated to your wife of almost 48 years. And you have a colon after the dedication. And then you have a poem that you wrote called Revelations, in which in great part is about time. And I wouldn't ask this particular question, which is almost like, I guess, a thought experiment, but I'm going to because it was poetic and loving and about time and great deal. So you have two lovely daughters. I have three daughters and a son who's now 40. So I remember when he was 3 years old and I threw him up in the air. And he's still coming down and I haven't caught him yet. And yet he's 40 years old now. He's a grown man. So where did that moment go? And you talk about the time is passing unbidden. You didn't ask for it to pass, and you bring the world back anew. So your life is devoted in great part to time. So where is he still in the air? Is he still there? It only happened yesterday.
Well, this is an excellent example of complementarity. There are different ways of approaching that question that add meaning to it and different perspectives, even though they may seem to contradict one another. So in physics, at a deeper level, we usually deal not in time and space separately, but in space-time. And so just as different places are available, even though they might be difficult to get to in practice, I'd like to think in some metaphysical sense that if from a God's eye perspective, space and time is just a thing. It's just not. It's not a matter of a universe in space that comes to be and passes away as time goes on. It's an organic whole. Now, of course, in our everyday experience, the past is memories and can't be altered. The future is things we can only guess will happen and try to influence. So that they seem very different, but one becomes the other. And fortunately, we can memorialize the past, using, of course, our brains, our memories, but also now with, in many, many ways, with photographs and recordings and digital media. So I think
it's kind of funny because
the past, well, William Faulkner said the past isn't dead, it's not even past. So I think that's I think the past is we can keep the past. It does, and I think the universe also keeps the past.
It's funny because May 15th you'll be 70, and next May I'll be 70, and I think both of us probably from time to time go, what the hell happened? Where I mean, it's just the other day that you were working on all this, and
that's true. In many ways, the memories are fresh, and there are certainly, I remember some things even about my childhood that seem, I can bring them to mind with pictures and details that, and in a sense, relive them. And then on the other, but there's a lot. I mean, it accumulates, and that's a wonderful thing about growing up and getting older. It accumulates, and also I'm looking forward to a lot of future. I don't.
Well, that's kind of what you say in your poem. It's beginning anew. You do say that at the very end, and it begins anew, which is a good way to end it because it's kind of circular, like many things are.
And I once posed to myself this kind of thought experiment: if you could start all over again, just wipe out your memories and start out all over again, would you do it? And then it occurred to me that if you wipe out your memories, then is it really so different from having a child or a grandchild and they get to start all over again? So it's not a choice that you need to face. You can live your own life and yet have new lives beginning that experience, experience the world afresh, and it's a gift. And if you widen your circle of empathy, sort of escape the prison of the self, which I think is a big message that deep understanding of the physical world conveys, then some of these issues about fear of death and worry and transience take on a very different character. They look very different. And
you talk about in your book about infants and the self, and then the other.
A lot. And being born again. That to me is to me in writing the book, that to me was the thing that surprised me most, that I resonated with this concept of being born again, that in coming to terms with how the physical world actually works, we have to get rid of many preconceptions. So as professional physicists have to unlearn a lot of things as well as learn things. And it's a great opportunity for mind expansion. And I feel very blessed that I've been able to, and I keep doing it and keep trying to question what I know and also learn new things. And I highly recommend it to everyone as a way of expanding experience, expanding your possibilities, expanding what you think the world is. And when you do that, you find some wonderful surprises, and that how should I say, these limitations of mortality and conditions somehow, at least for a while, can be transcended. You can transcend that.
But playing devil's advocate to a certain extent, and I've done a lot of interviews with extremely intelligent men and women who have attempted to explain the kinds of things that you do in fundamentals. And it's so funny because recently I interviewed Lisa Feldman, who wrote 7.5 Lessons About the Brain, and then Donald Hoffman, who wrote Galileo's Error, Rethinking Consciousness by Michael Graziano, Alan Lightman's Probable Impossibilities. And they all got mad at me, angry at me, at least the way I looked at it, because I said, well, what if it's a solipsistic universe? In which case our interview is not that important because only one of us is speaking. In fundamental solipsism. But if you look at it, the more metaphysical one, it's God. And you talk about other religions, that God is dreaming us. But what have you ever, I assume you have considered that, but if you do consider the possibility of solipsism, does it really make any difference? I'm only asking these questions because I have the opportunity to ask them to someone like you.
Well, nowadays I look at everything through the prism of complementarity, which to me is the deepest lesson that I've learned in my encounter with physical reality. That it's very concrete in the context of fundamental physics, that you can't do justice to reality without using different pictures that on the surface are even contradictory, certainly in great tension, and yet each adds something to your understanding of the subject or object you're looking at. And I understand that you can talk yourself into solipsism, and that at some level, yes, our brains are self-contained, or can certainly reflect on themselves in a way that is absorbing and doesn't. Now, I don't think it's the deepest understanding. I think there really is an external world, and it really is difficult ultimately to separate ourselves from that external world. I guess I believe in the higher solipsism, which is that the universe as a whole is thinking about itself and realizes itself in different aspects. But it can be sometimes instructive and entertaining to think about the maximal egotistical view of things and I'm not sure where you go from there, though. That
you can.
Yes, it is possible to ask questions about whether we're in a dream or not, and for instance, and I've taken that seriously. Actually, unlike I think most people who mention it, they don't. Well, not so much the dream scenario, but well, no, well, take the dream scenario. Okay, but then I'll come to a different version, which is somehow more popular these days. So if you have to ask, what does the dream scenario need to support it, and what does it explain? Well, it needs to support it some mind that's doing the dreaming, presumably. And what is that? Where's the evidence for that? That's not I prefer explanations of complicated things in terms of simple concepts when possible. And this is explaining something that seems straightforward in terms of something that namely that we're interacting with an external world, and other people have minds more or less like me. And so that in terms of something that's very different and doesn't, is fun to think about. But where did we get a model of a dreaming brain? Well, we got it from our own brain and our own experience. And do we really think that the worlds we spin out when we're dreaming have a more tangible reality? Do they really hang together better? Do they offer explanatory power that is beyond what we have otherwise available? And I don't really think so. But there's another version of this which is closely related to me. Well, pretty closely related, which is the concept that the world is a simulation, like in the Matrix movies and things. And some otherwise serious people take that seriously, but I think it's really kind of silly, because, well, if you do take it seriously, because first of all, you have to ask, well, if we're inside a computer and not really viewing an external world, but viewing signals within this computer, well, okay, what's the computer made out of? What have you really what have you really explained at all? You haven't, it's begging the question. And then if you look at the actual way the world is built, the actual laws that it obeys, it doesn't look like a programmed device at all. We have constraints in physical laws that only things that are very close by act on other things that are close by. We have a lot of hidden complexity. When you examine matter more and more closely, you find surprises and structures, and only a small part of that is used in consciousness and supporting things. So let me put it this way: if it's a piece of programming designed to fool us, it's a very poor piece of programming. It's very wasteful and doesn't use a lot of imagination.
And I think that's why the other authors were like, I was essentially telling them that what they were doing was not exactly right. So that's why they were upset with me. And it's funny because I am asking these questions of you because I've never had the opportunity, without sounding supercilious, I've never had the opportunity to ask questions like this to someone like you. So the second one, and somehow it connects in my mind, is why is one the number one? Why is it not prime? It used to be prime. And then, and I thought, okay, it's divisible by one, but it's also divisible by itself. And,
yeah.
And I still can't wrap my head around that.
Well, it's really a matter of definition and convenience. I wouldn't object to calling one a prime as long as you're clear about what the definition is. It's fine, but in mathematics, it's usually more convenient not to count one as a prime. For instance, I mean, specifically, the theorem, the main theorem, the fundamental theorem about prime numbers is that if you take any number, you can decompose it in one and only one way into a product of primes. And that's true if you exclude one as a prime number. But if you include one, of course, you could include any number of ones in the product and it would still be the same product. So if you want the fundamental theorem of arithmetic, this unique decomposition into primes, to be true, it's better to define things so that one is not a prime. So this is actually typical of mathematics and physics. We we work towards definitions, and sometimes we have to modify definitions as time goes on. You know, what the concept of energy, for instance, has a very rich history of refinement and changes over the course of physics, of the development of physics. Of course, the notion of what a particle is has drastically changed from the atomism of the Greeks to the modern concept, which is very much richer and more subtle, and yet also more precise. And then
yeah, and you talk about Democritus, and I wondered in my head when I was reading about it, okay, how far have we come? How far have we really come from that insight that so many thousands of years ago that he had? And
yeah, well, he had a wonderful insight, but I would say it was more promise than delivery. So his insight, or his program, his program was to understand physical reality on the basis of just a few basic concepts, rather than the vast array of concepts we use to talk about the world in everyday life. So he said, I don't remember the exact phrase, but basically saying that cold and hot are illusions, and color is an illusion, and that in reality there's just atoms and the void. And atoms were supposed to be these ideal little objects that had only size, no other properties, and some primitive kind of motion. And that's very much the program that's actually worked in understanding the physical world. But the details are quite different. I mean, the atoms don't really have sizes and shapes. They're points and yet they have quantum mechanical uncertainty. They have properties of mass, charge, and spin. So we can say exactly what the properties are, and everything else has to be explained in terms of those, and nothing else. And we do that. So he had his vision, I think, has been fulfilled beyond what he possibly could have imagined, in terms of precision and depth and power. But the details are different. It's not just atoms that are hard, little spheres or little tiny balls with funny shapes. And very important, we have equations. He had words. We have equations. That's a big difference.
He did the best he could. Well, and that's another one of your heroes, and Richard Feynman really is my hero. But and I like the fact that in that one picture that was connected to your Nobel lecture, you actually say the word hero. I was so happy when you said that. It made me feel so good. But another one of your heroes is Bertrand Russell. And here was another thing I've always wondered about in looking at Principia Mathematica. And as a bookseller, I'm looking for a nice 3-volume set of it.
I bet you don't sell many of those.
But the thing is, I always thought, okay, Gödel writes this letter, and I'm thinking, did he totally destroy? I've always wondered, did he totally destroy what Alfred Lord Whitehead and Bertrand Russell did? Sometimes, but okay, explain that to me then. It seems to me like it's a theorem of incompleteness, so they couldn't have done what they did. It's incomplete. It's not provable. That in my little mind, that's
I would say he refined what they were doing. He didn't, but built on it and showed a sort of unexpected richness, but also limitations of the structure. So it was that his paper referred explicitly to Principia Mathematica, if I remember, and what Gödel's work did to make a subtle story maybe a little more clear than it should be, is he showed that in sufficiently complicated axiom systems, there are statements that are true in the sense that any realization of the axioms will obey that statement and yet can't be proved from the axioms. So there's a difference between provability and truth. And that's a great discovery, but it doesn't mean you can't prove anything. You can still prove a lot. and it's still it becomes very interesting to figure out what you can prove and what you can't prove. And so so it doesn't overthrow it at all. And the basic idea that you should make your axioms as simple as possible and to explain as much as possible, which was the essence of the Principia Mathematica. They wanted to reduce arithmetic and other basic elements of mathematics to pure logic, to logical constructions, and they did that. So you can't prove that the logic is complete, and you can't prove that the arithmetic is complete, but you can prove that they are the same thing, which is what. So no, it did not at all. No, it's similar in a way to what Einstein did for Newton's theory of gravity. I mean, you could say that, okay, now it's a completely different theory of gravity. Newton was just totally wrong, and but that's not really the case. It's a theory that incorporates the previous theory as a limiting case, valid in many circumstances, and it explains why that theory is what it is. Also, why there are certain things it can't explain, or things that it can't cover, but it doesn't do away with the valid consequences and applications. And in fact, both Gödel's work and Einstein's work would have been inconceivable without the earlier works to build on.
Yeah, standing on the shoulders of giants. And twice you've said something that reminds me of Einstein saying, and in the book you did too, and in all the keys you said too, it's like, make it as simple as possible, but no simpler.
I had that constantly in mind as I wrote this. But this book was written, as I said, I wrote in the book for my friends who asked me, what do you do and what's going on? I read about these exciting things in the newspaper that I don't understand. Are they really true? What's the actual story? And I wanted to make this really fun and profound and powerful understanding of the world that I've enjoyed and helped to discover and gradually assimilated over my career. I wanted to make it available to everybody, to intelligent people that are curious but don't necessarily have a lot of knowledge. So I tried. So it's all in English, no equations, basically. And really also touching on the kinds of questions that I think people want to know about, what things that are often consigned to philosophy or even theology. You know, what does it all mean? Of course, I don't give definitive answers to what it all means, but I think, give an honest account and a rich account of what we do understand and what that tells us about questions like that, and also what we don't understand and what we can hope to understand in the future that will let things progress further.
Well, one of the things that is calming about the book, as if you try to make people calm down. It's not that bad. There's plenty of this.
Well, this reminds me very much of another statement from Richard Feynman. He said,
"There's plenty of room at the bottom."
Well, that's another memorable one, which I played on. In fact, with there's plenty of this and there's plenty of that. But he said, "What one fool can invent, another fool can understand." That's profound. It sounds like a joke, and it is a joke. But it's also profound because it's much more difficult to discover something usually than it is to, having discovered it, to explain it. You find simpler ways to get to the path. There are a lot of wrong roads that you avoid. Once you get there, so that the clouds lift and you get a view from a height, and you can find easier ways that you could have gotten to the top, and you can also see how it relates to things that are down below. So that's a real phenomenon. And in computer science, it's even a very precise thing. You may have heard of the problem of P versus NP, which is thought to be the holy grail problem, the unsolved problem of computer science. And it's basically the statement that P is things that you can compute, very roughly speaking, compute in a reasonable amount of time. NP is the things that you can explain in a reasonable amount of time. And I'm sorry, it's the opposite way around. P is the things that you can find or prove in a reasonable amount of time. NP is the class of things that you can explain once you found the answer or verify the proof in a reasonable amount of time. And those are quite different. The people haven't proved that they're not the same thing, but it's widely expected that they're not the same thing. And in many examples, people have very good ways of solving, of verifying the proofs of things, but it's much more difficult to find the proofs. Or to go back to something we discussed before, say as something like taking a large number and finding its prime factors, is something that's very difficult to do. But once you've done it, you can just display the numbers, and it's very easy to verify that that's the answer. And this characteristic of things being very hard to discover, but then once you've discovered them, much easier to explain and understand, is very profound, and it really is one of the central messages of fundamentals that I think you got there.
The funny thing is that, and this is something that's happened to me, and I'm sure it has happened to you since you actually knew Feynman, and that one picture is him goofing around with you anyway in a humorous way.
Yeah.
So if you watch the Nova special, or the special when he's sitting in the chair saying the fun of finding things out, he does such a great job, especially when he's kind of pissed off at the interviewer for saying the why question. I can't answer a why question, and he gets kind of mad. But the thing about that hour is there was a big smile on my face the entire time, and I've never quite understood why everything he says. It's not that I'm laughing, it just makes me happy. But do you have any idea of what I mean when you're listening to him talk and explain these things, like why the woman is slipping on the ice and the ice turns into water?
Well, yeah, I mean, I don't let you in on a dirty secret. It's not very dirty, but he had a lot of experience answering questions like that, and he had very well rehearsed answers, and
I know.
And shticks to go with it. So it was very polished. It was not, but he made it look as if he was improvising.
Like his father telling him about his father telling him about the names of the birds, or the chessboard. Yeah. The chessboard.
Yeah. So it's just a marvelous performance that a brilliant guy has thought very hard about how to present these things and polished it, and it's great. But also, even when he's confronted with something new, it's a joy to see the mind at work, because he has a rare quality, I think, that of actually listening to the questions and trying to address them when they're new questions, and really thinking about it. And you can see the process. And of course, he's a very brilliant guy who knows a lot and also is very quick. And so he comes up with surprises. And the other thing is, you can see that he himself is having a great time. He enjoys figuring things out. He really did.
Well, it's like when he's talking about he's sitting in the chair and he's talking about the electromagnetic spectrum, and you do this too. And he's saying, okay, we see this little tiny bit. Yeah. And he says, in Radio Moscow, and he says all this he goes, like, all this stuff is just flying, and I know it's rehearsed, but it seems as if he's amazed that there's so much stuff, and you convey that.
Just because he's seen it before doesn't mean it's not amazing. Each time you think about it, it is amazing. It is amazing.
It is, yes, it is.
I'm constantly amazed by things that I've known for years. They don't become any less amazing. In many ways, they become more amazing when you test them out and see that they keep working in circumstances that are very different from their origins and require a lot of logical processing to get there. And it's absolutely astonishing that, and I'm still struggling with the concept that the world that we have in a fundamental description, the quantum world with all this uncertainty and monkey business and qualities that are very, very different, as Democritus noted, from the qualities we actually relate to in everyday life and talk about with other people. And so to understand that the fundamental world is also the world of everyday life, including self-awareness, perception, as well as the many, many phenomena of color and just, metabolism, everything, that those are really the same world, is just a continuing miracle to me. And I keep, and as I understand more and more of it, I also, it's a continuing joy.
It's funny because you just used the word fundamentals, the title of your book, and the 10 keys. And that was the paradox for me too. And again, it goes to complementarity. You're giving us these 10 keys, which implies that there are locks. And I was thinking, okay, these are the keys that I can use to open some lock somewhere. What is actually the lock that I'm opening, and what's inside the box that the lock is locking?
Well,
and
I think of it as opening doors into, or opening windows into bigger views of what reality is, and also, of course, leaving behind things that are wrong or only partial truths, or ones so I mean, to take an example, for instance, the first key to reality is that there's plenty of space, and in everyday life we deal typically with human-sized objects, and then we realize, in a deeper understanding, that the universe is huge, that huge, and then on the other hand, so that's one insight that I think certainly colors the way I view reality. It puts things in perspective, and can widen your circle of empathy and just give you detachment from everyday disappointments or frustrations. But also, it can be depressing to think that, oh, I'm terribly small, the universe is so big, what am I, pitiful mote in God's eyes? But on the other hand, we're also enormously large compared to the structural units that can carry a lot of information and build up complexity. We contain also gazillions of atoms and neurons and things, and so we're also very large. So there's plenty of space on the outside. There's also plenty of space on the inside, and we really do contain worlds within. And so unlocking that understanding, I think, is both life affirming and also kind of wisdom that orients us in the physical reality.
One of the coolest things about this,
whether you like it or not, that's the way it is. But it's actually pretty marvelous if you think about it. Right?
Well, it's like when you're in college, you have these dorm room discussions when everyone's in whatever state of mind at 3 o'clock in the morning, and these are the questions that always come up.
Yes.
And then your numbers in your book are always the same, whether you're big, whether you're going this way or that way. It's always 10 with an enormous number of zeros after it. And then when you go tinier, it's 10. So my question in my life is, wherever we are we in the middle? So like we have, like you say, all the space and time there is. So no matter where we are, it seems as if we must be in the middle, right?
We're sort of in the middle, it turns out. I don't think we'd have to be in the middle, but it turns out, as far as space is concerned, if you take the number of atoms within a human body, it's roughly speaking, very rough, with astronomical accuracy, as we say, it's roughly the same as the number of stars in the universe, in the visible universe. And
within a factor of something.
Yeah, and if you take the number of thoughts we can have in a lifetime, which I'm very proud of trying. I made a serious attempt, although it's intrinsically a kind of vague question. What's a thought and how many? But it's a great discussion, if I may say so myself, of what that means and making it quantitative. If you make an inventory of how many meaningful thoughts you can have within a lifetime, it's a few billion, which happens to also be roughly the number of years in the lifetime of the universe. So yeah, so also in time, we're kind of in a good place, or in a medium place between the cosmic vastness and what it takes to be meaningful. Yeah. So, and whether we're exactly in the middle is kind of not the point. The point is that there's plenty of room at the bottom and also plenty of room on the outside. There's plenty of room for growth. Also, I would say one thing that we like. So it's plenty of place, plenty of time. But I also explain why there's plenty of matter and energy. And in general, the message is that we are not pitifully unendowed. we are actually are very well endowed in terms of the amount of complexity we have, the amount of thoughts we can have, our understanding of the physical world, and our ability to make interesting things and do interesting things to control nature. But there's much more. There's room for growth. We can do much more. So it's good news. That's the message, that we should be humble. There's room for humility. The universe is vast, but we should also have self-respect, because we have a lot of resources and we have powers of mind that are able to control the universe, and we have enormous opportunities for growth. I'm very optimistic about the future of mind in the cosmos.
Well, then again, I'll ask you a question, because you're the only person I could ever ask. I've never met anyone else I can ask these questions to. So if you go to the Planck length or the collapse of the wave function, or
yes,
Heisenberg's principle of indeterminacy, there's this place we can't look beyond. And then if you go to the age of the universe, there's a place we can't look beyond. So on both sides of your discussion, there are places we cannot, well, maybe we can, but at this point, we can't look beyond those places. Right?
Well, there are things we don't know, that's for sure. There are things we don't know. But in those cases, we know that we don't know them. It's like Donald Rumsfeld's known unknowns. And knowing the unknowns is already progress. And I don't think it's hopeless that we'll get, and in fact, it's happening. We're getting better and better knowledge about what happened in the earliest moments of the universe. It hasn't closed off in the sense that we don't have a complete story. And it may be that the concept of time itself breaks down, or we don't know. But we've understood more and more. We've pushed back the horizon, so to speak, and the horizons of our understanding have expanded. Also, in the internal world, We've made enormous progress. I mean, fantastic progress. If you look back just a few decades, our understanding of the physical world is on another level. Fundamentals of how physics works is on a different level. 100 years ago, people didn't know about quantum mechanics in its modern form. 50 years ago now, we didn't have the Standard Model, which really finally realized Democritus's dream of what are the fundamental properties. And so we've made a lot of progress, and it's not over yet. We still have to figure out what the dark matter is. We can push back the frontiers of the very small. We can make things that are more complex. We can sense the world in new and richer ways.
And it's funny what you're saying is so pertinent right now.
Practical problems like generating energies in ways that don't ruin the planet and things like that. But yeah, and we can certainly have an adventure in constructing new kinds of minds that are more powerful and will be partners of ours, and then maybe our descendants.
And then it's funny because I listened to your talk about the Large Hadron Collider, and it's pertinent, relevant that just a few weeks ago, something is discovered that may upend the Standard Model. And here you are.
It might. I'm not convinced. This is the muon.
No.
Yes. But let me put it this way. So this was a possible discrepancy in the prediction for the magnitude of the magnetic field that's associated with the spin of the element of a muon. And people did very, very accurate measurements of this to a part in a billion, how strong this magnetic field is. And it's not a simple number like 1 or 2. It's a very complicated number that had to be calculated. So it can also be calculated theoretically. Given, if we know what the Standard Model is, we think we have all the particles and we know the interactions, all the relevant things, we can compute. And it turns out that if you compute, it's fantastically right. It's right to within a part in a billion. But physicists worry if it's wrong even at a part in a billion. So this is an enormous testament to how well we understand things, as well, because there's no other field of human endeavor in which you worry about discrepancies like that. You don't do it in chemistry. You don't do it in economics. You certainly don't do it in biology. But physicists are we have very, very high standards of precision, and if things seem to be off by a part in a billion, it sets off all kinds of alarm bells and excitement. And now, fortunately or unfortunately, though, now there are two competing calculations of what the magnitude should be. An older calculation, which was based on extrapolation of other experimental results, and a newer calculation, which just uses the fundamental theory and powerful computers to estimate, to get the magnitude of this magnetic field. And the newer calculation actually agrees with the experiment. So it's not clear that there's a discrepancy at all. So I would say for sure it's a triumph that we can get within a part in a billion. Whether we're going to have new adventures to get that last part in a billion, or just the triumph is complete, that remains to be seen.
Well, what's so interesting is, it's like you said, when that happened, it makes headlines around the world, although no one who reads it understands exactly what it is. And it's just like with you and time crystals. If you go to YouTube, everybody has a little block of a crystal of something, and they pretend like what you've done is created a time machine.
No, I wish, but no, it's not a time machine, but it may be a way of getting more accurate instruments and more accurate clocks, and it So it might be useful, but it for sure is uncovering a whole new class of states of matter and behaviors that were previously unanticipated and fascinating.
You find it useful that you guys always have to speak to the general public in terms of metaphor, like the fact that people can only equate what you did in terms of looking at a crystal that spatially does what you're talking about in the temporal sense. So
yeah,
there's always a metaphor, whether it's Einstein and the moving trains, no matter what you explain to us, it has to be in metaphor, except when Feynman says, don't ask me a why question because I can't give you a metaphor for it.
Well, it's a challenge to make metaphors, and it's a creative endeavor, and it can be done at different levels. Okay, so ultimately, the description that supports the kind of precision we're talking about, and is the gold standard, so to speak, in understanding the physical world, is mathematical in equations, and has to be very precise, and there are algorithms that go into unfolding the consequences of these equations. However, time crystals is a good example. It started as a metaphor. I mean, I was thinking about ordinary crystals and saying, well, okay, why? So that's atoms in space. Why couldn't you have events in time? And so that's what it starts as, metaphors. So even in my professional work, I'm always using metaphors and trying to explain things in different ways. And then typically it almost always goes from the kind of top down. You start with a metaphor and then refine it into equation. At least me, I refine it into equations. There have only been a few cases where I sort of stumbled into an equation and then worked out metaphors for what it means. That happens too, but it's more rare, I would say. Well, both happen, but it's definitely part of my professional life to use metaphors, because the equations are too complicated to solve. When you put them in new circumstances, you have to have intuitions about how things are going to behave. In fact, one of the great physicists, Paul Dirac, said, "I understand an equation when I can predict its solutions without actually solving it." Or I can picture its solutions without actually solving it. And if you think about it, that's metaphors. And so if I'm thinking about, I want to show that anyons exist. So what is, you move these particles around and they have some effect, and how could people actually with instruments try to detect this effect, or axions? Similarly, you have these fields, and I view them in very different ways, but one way is the equations, but another way is just these things sloshing around in space and tickling the electromagnetic fields, which are little wires that go back to Faraday with lines of force, and so what happens, and you have to be able to think in different ways. It goes into complementarity, but it's also it's a creative activity, and I love it. It's wonderful to. And going back to the original question, I guess these metaphors are very, very powerful. Metaphors that are developed in the context of understanding the physical world precisely, where you have feedback, you have experiments, and they can tell you when you're wrong, and you have to do better. The kinds of metaphors you develop really stretch your mind, and can then, with your mind stretched and expanded and sharpened, you can take that kind of experience and stock of ideas and bring them to bear on questions that were once thought to be philosophical or even theological. I think we have, I don't think you can be a decent philosopher now, if you don't understand quantum mechanics. You just can't. You don't understand physical reality properly. You haven't had your mind expanded, so you're not capable of understanding physical reality. Right?
But Feynman made fun of philosophers. But which reminds me,
philosophy, and I still read philosophy and learn from it.
Well, that's where I was going to ask you is because,
for a philosopher nowadays to think that they can do their job without taking into account the surprises, the mind expanding perspectives that are opened up by our much more profound understanding of the physical world is a big mistake. I mean, that's just not using the tools at hand. So
one of the things that reminded me of that was, in your Wikipedia entry, for example, you're described as a pantheist. Pantheism is what they put you in that box. And then it reminded me of how the Dalai Lama meets with the quantum physicists, or I don't know if he still does, every year. And it's kind of like what you were talking about. And that's kind of a complementarity also that you have coming from this philosophical, not religious, but spiritual way and then each year they seem to get closer and closer.
Oh, I think it's wonderful that the Dalai Lama is listening to us. and we listen to him too. So it's good. And yeah.
He has that same kind of sense of humor as Richard Feynman. He's always joking about everything. It's so funny.
He just radiates joy. So there are certain people that radiate joy, and
I know.
Is another one, right?
It's funny. I think a sense of humor is an element of all that you do, but I can't really quantify why I feel that way. But there is something about, this idea of curiosity too, retaining the curiosity of a child.
Yes.
And you still have, I assume.
Oh yeah. Oh yeah. I always want to know how things work, take them apart. I make a point of doing things with my hands, building, and anytime I see a puzzle, I feel compelled to try to do it. I waste a lot of time actually, but yeah. So and I really enjoy playing with children too.
Likewise, I'd rather sit at Thanksgiving or Christmas. I would much rather sit at the kids' table, who are they're interesting, and sit with a bunch of boring adults. I've always been like that. But in your book, and also in maybe apocryphal stories about you, it talks about how when you were a little kid, how much you loved large numbers. And
yes, yeah, I did. Right. So I felt very powerful that I was able to discover ways of making really large numbers. So basically, I was very ignorant at that time, of course. But
what's your first memory?
My first memory is, I think it's the first. I have two memories from very, very early. One was when I fell off a bicycle, and I remember my grandmother was holding me and helped put me in front of a mirror, and I could see blood streaming down. I remember that, but that's not the interesting one. The interesting one is I remember sitting in our kitchen in Port Washington with a coffee percolator. So this was this thing that you could take apart and put together, and just realizing that I could take it apart and put it together, and doing it over and over again until I could do it very well. And that somehow, it was a pre-verbal experience, because there were no words. I see it all in pictures, and somehow that's when it dawned on me that there was a self, that I was, that there were things that I could move myself, and then there was an external world that also could be controlled, but it was different, right.
It's funny because I remember my grandmother, and it's similar because it was a tea kettle, and we were sitting in the kitchen table looking at the tea kettle, and I was talking to her about what the water boiling actually meant and how it could be done. And it's my grandmother, who was lovely and intelligent but not studied, and she looked at me and she said, if you look at that teapot long enough, there's the possibility that the water might boil.
Well, you have to be very patient for that.
But it was something that made me start thinking about, yes, there's,
Yeah.
and well, then we could talk about entropy. We could talk about entropy and why, and you do talk about it in the book.
A little bit, yeah.
Yeah, and that's another one. Okay, I can only ask you. I mean, is this, are we all, is it going to be, you know, the big chill? Is it all going to just stop moving? Is
Well,
that
the honest answer is I don't know, but I doubt
right?
it. The
Really?
you know, yeah, yeah, because I wouldn't underestimate the ability of creative intelligence to create, and uh, and
Wow.
we've learned ways of making do with less and less energy to do more and more. And in the quantum world with quantum computers, they can run on very little energy. Time crystals in principle can work on what can keep going with no energy at all. So they can cycle through things, and if they're really complicated, they could embody experiences. And but anyway, the big answer is that, as I was saying before, if you go back 100 years or certainly 150 years, our view of the universe was so different, so paltry compared to what it is now. And every one of the fundamentals I discussed looked very different 100 or 150 years ago. And I don't doubt that they'll look very different again many times before a billion years have passed. And so since the threatened heat death of the universe is billions of years away, I don't think we can safely extrapolate to that at all.
I agree with that.
I think it's kind of silly, actually. We have much more immediate problems.
I could go on for days with you, but we spent well over an hour. So the last question I'll ask you, and I noticed it when you were addressing the Royal Academy, Royal Institute, is you have 6 pens in your pocket, and you have 6 pens in your pocket now. And I
I have
always
6.
wonder,
No, I have 7. No, I have 8 now.
well, why? The question is why? There's a good question. Why is it necessary for physicists to have 8 pens?
Well, basically because I can't fit anymore. It's frankly, half of it is to say as a conversational gambit. People ask me why was it my grandson really at one point loved taking them out and putting them back in. But I use it. I have not only pens, but I have file cards, and I jot down ideas, and sometimes it's useful to have different colors. Also in certain kinds of puzzles, it's very, if you use pens so you don't have an eraser, it's really important to have different colors so you can explore different possibilities. And you know, if you use a pencil, it gets very messy. So I like to have pens with different colors, just in case there's an interesting puzzle that needs exploration of different branches of a tree, so to speak.
Well, anyway, so thank you so much for being here. Your book, you know, since I have this bookstore, your book's on the front shelf and it's also in the window. And
Well, I think a lot of people could derive a lot of joy from it, and
I do too.
I'm very pleased with the effect it had on me. It really deepened my experience of the world and got me in touch with my my teenage self that was asking these kinds of questions, and I think it's been very well received.
Well, I kind of look at it as, I hope you continue to write books, but I kind of look at it as a capstone of the previous 4, because
oh yeah, it's different. It's a capstone, but it's also more foundational in a sense. I think it's more accessible, it's more digested, and it's really aimed, as I said, at my curious friends who complained about my previous books that they're too technical, too advanced. This here I really tried to address the most profound lessons in the simplest way possible, but it's honest and really gets you to the frontiers, and then even a little bit beyond, because I think, very interesting, clearly labeled speculations about what comes next.
Well, when you're reading, it's funny because when you're reading fiction, and I interview fiction authors, I always say it's really nice when you make the reader work to understand what the story, and then at the end, you're not quite sure if it's really the end. And I think that's the way the book ends, is that, okay, this is a place where I can continue to think about what was said.
Right.
I think that really means a lot in a book, don't you?
Thank you. Yeah, I do. And yeah, and that's very much in the spirit of complementarity, which is
Exactly.
really the capstone of this book. And in many ways, I think is, well, it's not the capstone of what I hope to achieve technically in
No.
science. It is the capstone maybe of the wisdom I'm going to achieve in science.
Well, thank you so much for being here. It was a pleasure for me, and I hope you enjoyed it as well.
Yeah, thank you very much. Great. Okay, good.
Okay,
And,
see ya.
yeah, you radiate too, like Feynman, or you're just smiling and like the Dalai Lama. I hope I do.
But
too.
I don't know why it makes me happy.
No.
That's a good question, but it just, yeah, you're right. I can't stop smiling.
All right. Okay.
Okay,
Bye.
see ya. Bye-bye.